We're going to be learning about exponential growth and decay questions, and these are using exponential equations. So our normal exponential equation was y equals a times b to the x power. And so we're going to use that here today, but each of these things is going to represent something different. So y, or it could also be f of x, is going to be our ending amount. A is going to be our starting amount. B is going to be our percent. But this needs to be in terms of a decimal. And last but not least, x is going to be our time. And we calculate that in years. So you got to be really careful. The percent must be in a decimal and the time must be in years for this formula to work properly. Now, another thing, a couple of other things, we have exponential growth and decay. So when is it growth or when is it decay? We're going to have exponential growth. We're going to have exponential growth when that b value, that growth factor, is bigger than 1. That is bigger than 1, then our numbers are going to be getting bigger as we go and we have exponential growth. For decay, we're going to have exponential decay if that b value is between 0 and 1. So if it's a fraction or a decimal b value, that is where you're going to have exponential decay. A lot of the examples we're going to be seeing are going to be exponential growth. Talking about money going into accounts is typically what we're going to see. But it could also be decay where things are getting smaller. The last thing that we need to talk about before we actually look at some examples here is what b actually is in terms of our percent. So for b, that's always going to be 1 plus or minus the percent that they give us in the question. And it's plus or minus because if it's growth, you're going to take 1 plus that percent. And if it's decay, you're going to take 1 minus that percent. And we're using that 1 because you're starting with 100% of something to begin with. So we're going to use this in practice with 2 examples here. So the first one we have says, suppose your parents deposited $1,500 in an account paying 6.5% interest compounded annually. Write the equation to model the situation, so that's the first thing we have to do, and find the account balance after 5 years and 18 years. So there's 3 parts to this. The first part is going to be writing the equation in general for this situation, and then the second thing is finding the account balance after 5 years, and then after 18 years. Okay, so our general equation, we're going to have y equals A is our starting amount. So how much money did our parents put into this account? They put $1,500. That is our starting amount. Times our percent. So even over here, let's do this first. Let's write out, we have what A equals, what B equals, and what X equals for things. Okay, so A is our starting amount, that's 1,500. B is our percent, but it's going to be 1 plus or minus. So if our parents are depositing money into account, that means that we're going to take 1 plus the percent that they gave us. Now, 6.5 is a percent. We need to turn that into a decimal. So I'm even going to go above here. We have to turn 6.5% into a decimal. Well, how do we do that? Remembering back to middle school, to turn a percent into a decimal, we're going to move this decimal places 2 spaces. So that means that we're adding 0.065. Okay, and if you take 1 plus 0.065, that's going to give us 1.065 as our b value. And then we're taking that to the x power. Okay, so x is talking about time. We don't really have to write anything down for that at the current moment. The next thing they want us to do is figure out how much money we're going to have after 5 years. So let's think for a moment. If we're depositing money into an account and we're getting interest, that means they're giving us money for free, essentially, into our account. That means that should we be getting a higher amount or a lower amount than the money we started with? That means that we should be getting a higher amount. Now, 6.5% over 5 years, not a ton of time or a very high percentage, but it still should be bigger. So if we're getting an answer smaller than the $1,500 that our parents put in there, we know we did something wrong. All right, the next piece is to find what happens after that 5 years. Okay? Well, if we have 5 years that have passed, that means that our x value here is going to be 5 years. So we're going to plug in that x value of 5, and we're going to see what we come up with here. So we have 1,500 times 1.065 to the 5th power. And here we're getting 2055.12999512. Okay, so let's talk about the context of this question and how many decimal points we should be using and how we're going to round this. This is talking about money. So for money, we use 2 decimal places. That means that we're going to have $2,055.13 because that 9 rounds that 2 up. So after 5 years, our $1,500 has grown into $2,055.13. So not too bad considering you're just putting it into account. You're not using any of that. You're not doing anything with it. You're just getting that interest. So let's see what happens after 18 years. So we've got more time that has passed. We still have that original $1,500. It's still paying us that 6.5%, and then we're going to take that to the 18th power because 18 years have passed. So here we have 4,659.98. So we're going to round that. That 1 does not round it up. So we have $4,659.98 is how much money would be in our account. Again, this is assuming you're not doing anything with it. You're not depositing more money, taking any money out. You're just kind of letting it ride for that amount of time. Okay, let's look at a slightly different one. It's not talking about money. Money, we all like money. It's very typical examples, but it's not always the only type of example we'll see. So here's another one. Since 1980, the number of gallons of whole milk each person in the U.S. drinks each year has decreased by 4.1% each year. In 1980, each person drank on average 16.5 gallons of whole milk per year. Write the equation to model the situation, so that's step number 1. And then find the approximate consumption after 3 years, that's the second thing, and 20 years. So again, we need 3 different things to answer this question, right? The first thing is to write what our normal equation is. So let's even come up with our A and B values, because those are the important things from this that we need to be able to pull information from the question to write down. So A is our starting amount. We're talking about the amount of whole milk the average person drinks per year. So what was the starting amount? That was 16.5 gallons. That was in 1980. Our B value is going to be the percent. So it says here that our amount each year has decreased by 4.1%. Is that going to be growth or decay? Since it's decreasing, we're going to take 1 and subtract that. Okay, so if we have 4.1, let's do this up here really quick. If we have 4.1 as a decimal, and we got to turn that into as a percent, we got to turn that into a decimal. We're moving it 2 spaces over here. So we're taking 1 minus 0.041. That's going to give us a B value of 0.959. Okay, so it should be less than 1 because we're getting smaller as we're going. Okay, we have Y equals our starting amount was 16.5 times our b value, we just figured out, was 0.959, and that's going to be to the x power. That's your equation in general for this situation, no matter how many years have passed. Next, they ask us, okay, they tell us 3 years have passed. 3 years have passed, so let's see how much milk consumption on average there is. So we're taking that equation we just built, and we're taking it and plugging in 3 for x. So if we do that, we're getting 14.55257, and it keeps going on from there. We're going to round things to 2 decimal places, just kind of as a customary thing here. So we're going to have 14.55. Now, in the last example, it was money, so we had to write the dollar symbol. Here, you have to give us a unit of what's happening, and so we're talking about the gallons of milk that are being consumed on average. Okay, so that means that we're going to put gallons with this as our answer. It also asks us in the question for what happens after 20 years. And so there, we're going to take that original equation again and plug 20 in for our exponent. So let me bring this back up here. We're going to change that exponent to be 20. And we get 7.14 gallons as our answer. So in this situation, we have to make sure, does it make sense that our numbers are getting smaller like that? We started out with 16.5. It's decreasing. So that means that each year that goes on, it should be getting smaller and smaller as it goes.